Alright guys, welcome to PreCal. This is 2.2.4 and we're going to be talking about transforming our sinusoidal functions today. So to start off, we're going to there we go, take a look at the graph of sine of x, right? So the base graph there, pull it up, it's supposed to have, go. There. Okay, so I'm going to graph sine of x. Okay. If I want to shift that pi over 3 to the right, so to get a left-right shift, I would need to have my minus h thing here, right? But here I want my h to be pi over, sorry, I forgot, pi over 3. Okay, so let's change that to just pi over 3. So that's going to be that same graph, but shifted over. So I'm going to put sine of x just so we have a point of reference. So my blue is my original. So my red graph is that same graph but shifted to the right, pi over 3. Okay. Then, what if I want to move it 2 units up? Right. So instead of right, I want to move it 2 units up. So I would put that plus 2 on the end there. Right? Now everything here is vertically moved up by 2. Okay. So why that is happening? Okay, if I zoom in here on this first one, that was a minus pi over 3. Try a decimal there. There we go. So on a basic graph here, so let's change my units to x-axis being 0 to 2 pi, and I will step by pi. We'll do pi over 2 to make it a little bit nicer for us. There we go. Okay, so the key points on a basic sine curve, right? We have our 0, 0, our pi, and our 2 pi. Those are where we kind of start, cross, and then end, right? Halfway in between these, I'm going to have my maximum point. And so in this case, halfway between pi and 0 is pi over 2. So there's my maximum. Halfway between pi and 2 pi is going to be my minimum. That's 3 pi over 2. So to get this shift, right, of going right, pi over 3, I literally need to move every single one of those right pi over 3. So if I add pi over 3 to all of those values, I now know where I'm going to start, right? So if I add pi over 3 to 0, I get pi over 3, right? If I add pi over 3 to pi over 2, I get 5 pi over 6, right? If I add pi over 3 to pi, I get 4 pi over 3, right? And if I add pi over 3 to 3 pi over 2, I get 11 pi over 6. And then if I add pi over 3 to 2 pi, I get 7 pi over 3. So that's how I can find those new points after I've done that translation to the right. I literally just take, hey, here's the key points for the base graph, shift all of those key points over, and then now I know where my key points are. Another way which you can do it is say, well, I know where the very first point is, which is at pi over 3. I know where my last point is, which is going to be at 7 pi over 3, because I just added pi over 3 to 0 and 2 pi. Then halfway between those, 4 pi over 3. Halfway between these two, 11 pi over 6. Halfway between the first two, 5 pi over 6, right? So you can do that graphically. Don't try and worry about every single point like we did when we made these with the pasta. Just try and find, hey, here's the key points where it's going to cross. Halfway between those it is another key point. So have those maximums and those intersections, and you're typically good to go as far as the graphs are. Now, what if I want to do a shift that was up 2, right? That one's actually going to be a whole lot easier because there's no pi's in it, right? So this point, which was 0, 0, is now up here at 0, 2. What was at pi over 2 is now at, sorry, at pi over 2, 1 is now at pi over 2, 3. What what was at pi 0 is now at pi 2. Well, what was at 3 pi over 2 negative 1 is now at 3 pi over 2 positive 1, right? It's all just 2 higher on the y value, and hopefully that one is not too bad for us to actually have to go and translate. Okay, so let's take a look at 94 through 97. So what I want you to do is actually pause here, work through 94 through 97 on your own. It's probably a little bit small on your screen here, so if you want to pull that up on a separate tab and do it there, by all means do that, and then come back and we will go through these together. Okay, so now that you've done those, we're going to take a look at these in Desmos. So I'll pull up my other tab. There we go. All right, so our first one here, we had sine of x minus 2. So that's going to be the same sine curve, but every y value is now 2 lower. So it should end up looking kind of like this, right? So it would be, it's normally here, and now we just got it shifted down. Okay. For the cosine of plus 1, that's going to be my cosine curve, but all up 1. So it normally starts here at 1 and goes down. Now it's going to start here at 2 and go down. And it'll actually bottom out on my x-axis. Then here I have a shift right of pi over 4. So now I'm starting over here at pi over 4 as opposed to starting here at 0. For my cosine, if I add pi over 2, right, I'm now going from where I normally would start here, now moving it left, pi over 2. So I'm going to start right there. And then for here, I'm going to the right pi over 4, so the same thing as I did here, but also down 2. So it's really a combo of this, and it gives me that. Right? And then lastly, this is a combination of this, and we end up getting that, where we move left pi over 2 and then also up 1. Last thing that we do there, I think that's on the next problem. Right, yeah, okay. So next they talk about the amplitude. If I put a number out front, right? Our standard sine curve, let me just graph that. So I can't capitalize. Okay. Has a maximum point here at 1. So if I put a 3 out in front of that, right? If you think about what that does for other functions, is it stretches it by that much. So everything's now 3 times taller, right? So where it did peak at 1, now it should peak at 3. And where it did bottom out at negative 1, now it'll bottom out at negative 3. And if we graph that, that's exactly what we see, right? It has the same x-intercepts, but we just stretch everything vertically so that we're getting the amplitude now of being 3. And again, amplitude is the term which we use for the distance between this midline, the line that goes right through the middle, up to either a peak or down to a valley. It's the same distance. So in this case, 3, but the base amplitude is a 1. So then on the cosine, right, I'll also graph this as a base cosine. This should take all of my cosine values and reduce the y's by half. So I should get closer to that x-axis. And if I do that, lo and behold, that's exactly what happens, right? I still have those same x-intercepts, but now all of my y values are half as tall as they were originally. Okay, hop back over here. So then as we hop over here to 96, if we take a look at the graph of sine compared to the graph of negative cosine and negative sine, how those all start. Well, a sine curve should start at the origin and then go up, right? As I go left to right is what I'm talking about. So a standard cosine starts at the top and then drops down. But if I make it negative, I flip the entire thing over, so I'm going to start down and end up going up. And then for my sine, if I make it negative, where it would normally go up, now it's going to start to go down. And we can see that on Desmos. If I graph these, here's our standard sine. If I make it negative in front, now I start by going down as opposed to going up if it wasn't negative. And cosine, again, starts on top and goes down, but if I make it negative, now I start down and go up. So hopefully that wasn't too terribly challenging for us. Okay, Now we're trying to figure out, well, how can we take a graph of sine and write it as a shift of cosine and vice versa? Because as we've talked about and hopefully seen quite a bit, I really get the exact same graphs for sine and cosine. It's just a matter of them being shifted in a different way. So how can I get this? If I want to change my sine to look like my cosine, I need to move this point over to here. Right? I could also say, hey, move this point over to here, or move this point over to here, but the nearest one is here to here, right? So this is me needing to move left pi over 2, right? So if I change my sign to go left pi over 2, if I put plus pi over 2, that took my sine curve, moved it left pi over 2, which is 90 degrees, and put me exactly where my cosine was, right? Which hopefully makes sense. If you think about your unit circle, which we did, right? If I take this and I turn it 90 degrees, now my sines are my cosines, right? And that's effectively what we are seeing here. So what if I want to go the other way? What if I want to change my cosine to get to my sine? Well, same thing to get from here to here. That's me moving it right, pi over 2. So I'd say, well, that's the cosine minus pi over 2 on the x, and now I'm where my sine is. So for this reason, there's really not a big benefit in using the cosines ever, right? We still use them mathematically, but when you get into the real world, when you're trying to graph like sound waves or any kind of wave, we always use sine because it's nicer to have it kind of start here at the origin versus having it start at the amplitude, at the maximum point of the amplitude. So if we ever need it to be different, we can just shift it and it does the same thing as a cosine would. So that's why they're called sinusoidal, because sine is kind of what we always default to, even though cosine kind of does the exact same thing. It's just a little bit not as convenient for where it starts. All right. So with that, we're going to hop back over here. And we got a little bit of notes here. So just about some kind of terminology here. So a cycle is one full time until you're back to where you were. So our cycle on both of these was 2 pi because it took us a distance of 2 pi radians to get back to the original. So that's one cycle. That's also the length of it is called the period. Okay, so cycle and period are almost interchangeable. The cycle is referring to the thing that is happening, whereas the period is referring to the length in which that one cycle happens. So one cycle is one period in length. You're going to hear the term period used a whole lot more than cycle because we typically care about the length more than we care about, hey, it's a cycle, right? All right, and then the other term we've kind of used today was the amplitude. So the amplitude, again, is that distance from the midline up to the peak or down to the valley. They're both an amplitude. Right? All right, so last thing here, a little bit of a closure. We want to try to say, hey, can we write an equation that would match these particular graphs? So let's say we want to use sine. Okay, it doesn't. So we could use sine or we could use cosine, whatever we need. So let's take a look at A. So I see my amplitude here is 2. Amplitude is really easy for us to find, especially if it's on the x-axis here. So it's an amplitude of 2. I'm probably going to want to use a cosine here because it's just a cosine but moved over this much. What that distance there is, well, if this is pi, this is cutting it in thirds, so that's pi over 3, 2 pi over 3, half of pi over 3 is pi over 6. So I want to move, so this is my cosine graph, moved right pi over 6 with an amplitude of 2. So what that graph would be based off of my estimate here. I'm going to get rid of all this junk. Would be 2 times the cosine of x, but I moved it to the right pi over 2, so minus pi over 2. And that would be what the graph was. Again, the scale's going to be a little bit different here, but there's my graph. All right, then the other one that we're looking at, so what do I see here? Well, I see my midline is right here, so I got shifted up 1, 2, 3. So it's going to be plus 3 on the very end, because that's how I get those vertical shifts. Right? My amplitude is 1, because it's from 3 to 4, or 3 down to 2. And then I could do a sine curve that has been shifted over this much, or a cosine curve that has been shifted over this much. I'm going to go sine because it's a little bit less. Again, each of these lines is pi over 3, so halfway there is pi over 6. So that is a sine curve moved to the right pi over 6, and it has an amplitude of 1, and it has a vertical shift of 3. So let's go ahead and graph that. So I want sine, I do not need a number in front, and I want it to go right pi over 6. And then I also want it to go up 3. And there is my graph. So that's what we want to be able to kind of go and do now, is be able to look at a graph and be able to determine the equation of it from the graph. That's where I want you to get. You shouldn't be an expert quite yet, but as you get more and more comfortable with doing these, hopefully we're going to get to that point. All right, so with that, here is our homework for 224. We're going to be doing 99 through 106, and I will talk to you guys next time.